Welcome to lesson 1 of 3 in our series in working with fractions. In particular, this series will be looking at, in this lesson, addition and subtraction of fractions, and in the next lesson we'll be looking at multiplication and division of fractions. And then our third lesson will have a range of GCSE questions for you to check in with. Okay, let's start with addition of fractions then. And fundamental to this is understanding equivalent fractions. It's the key for this method. So we are going to have a quick look here at equivalent fractions. Just a quick check-in. Have a look here. I'm going to highlight 3/5. It's in 5 sections, so I'm going to highlight 3 of these sections. That's 3/5, no big deal. In fact, I think you'll find this first section very straightforward. If I want to make an equivalent fraction, supposing I want to make it into tenths, well, visually, what I do is I take my shape and I split it in 2, okay? So the pieces are going to be, number of pieces can be multiplied by 2. Do you see? So I now have, because I've multiplied by 2, I've got 10 pieces in the whole shape. The number of them that have been highlighted have also been multiplied by 2, giving me 6 highlighted pieces out of 10. And that's the key to equivalence. Equivalent fractions, whatever you multiply the top of the fraction by, you multiply the bottom of the fraction by. And there you have it. Just a quick one to check in before we get started. If I want to change 3/5 to 40ths, and you will find this will be a key skill, then how many times does 5 go into 40? It goes in 8 times. I'm multiplying by 8. The principle we've established, whatever you do to the top, you do to the bottom, and vice versa. So I've multiplied the 5 by 8 to get 40, so I'll multiply this by 8 to get 24. Now I know I could simplify that. I'm not going to right now. My main purpose of this is, can you understand equivalent fractions? Because that's going to be key for the next thing. So we are going to use equivalent fractions to help us add fractions. Now, addition of fractions in some form is in every exam series, okay? I'm going to put 2 very easy cases before you, and you might think, oh, that's easy, but there's a fundamental principle here you've got to get. And if you get this principle, you'll be able to add any fractions. So let's have a look at this. If I was adding 1/4 plus 1/4, what would you think that would be? If I was having 3/4 and taking away 1/4, what would that be? I'm just going to illustrate this with something I brought earlier. Let's see if this works. And I'm doing this to get that fundamental principle. I'm going to take this nice looking apple and make it into quarters. Let's see. Oh, that's a good start. Oops. So I've got quarters. So what fundamental principle am I talking about, which works regardless of the number? 1/4 plus 1/4 equals 2/4. Easy. They're the same size pieces. If I start with 1, 2, 3/4, I take away 1, I'm left with 2. Just taking away 1, easy. They're the same size pieces. Let's go to it here. 1/4 plus 1/4, straightforward, is 2/4. And I know I can simplify that. What you're doing is you're saying the pieces are the same size, can you see? Therefore I can just add across the top. Here also, the pieces are the same size. 3/4 take away 1/4. Well, 3 take away 1 is 2. Easy. Okay? Straightforward. If I said 1/8 plus 1/8 plus 3/8. How many eighths is that? Let's have a think. The pieces, can you see, are all the same size, and there are 5 of them. 1 plus 1 plus 3 is 5/8. Right. Same size pieces. That's going to be our key. So let me give you one to try. We are going to try 1/4 plus 3/5. Now these are not the same size pieces. So what do we do? This sort of question will be in your exam. It could be more complicated than this, but this is fairly standard. The 4 and the 5 are different values. We need to make them the same. What do 4 and 5 go into? Think of your times tables, or do 4 times 5 is 20. So I can make both of these fractions into 20ths. 20ths, okay? I'm going to consider, what have I done to that 4 to make it 20? I've multiplied it by 5. Now remember our skills check on equivalent fractions. If I've multiplied the 4 by 5, I must multiply the 1 by 5. So that is 5 20ths. And what have I done to the 5 to make it 20? I've multiplied it by 4. Again, equivalent fractions. If I've multiplied that 5 by 4, I multiplied the 3 by 4. So that is 12 20ths. Now, what I've done is I've done the apple. I've made them the same size pieces. You see, they're both 20ths. And I've got 5 20ths plus 12 20ths, which is 17 20ths. And that is my addition of fractions. So, what is the key to add fractions? Make the bottom of the fractions the same number. Make the fractions the same size. Okay? Good. Let me just give you one to try yourself. Have a look at this one here. I'm going to give you, this is quite an interesting one here actually, because it will introduce the next thing we're going to do. 4/5 plus 5/6. Now, it's yours to pause if you want to have a quick go at this. Otherwise, just sit back, but I'd like you to think, what are you going to change the 5 and the 6 to? Well, here you go. You could either do 5 times 6 or think of your 5 times table and your 6 times table, and you'll see they're both 30ths. 30ths, okay? Then we think to ourselves, right, how do I make 4/5 into 30ths? Well, the bottom's being multiplied 5 times 6. So multiply the top by 6. 4 times 6 is 24. Nice. And this 6, how am I changing that to 30? Well, I'm multiplying by 5. So I multiplied the top of that fraction by 5. So I've multiplied the 5 by 5 to get 25. And the 6 by 5 to give me 30. So I've made them both with the same size pieces. I'm just going to bring a little colour in. You know I like my colour. So I've made them both 30ths. Okay. Now I'm adding these fractions together. Because they're the same size pieces, I can simply do 24 plus 25, which is 49. Now, that's it, almost, addition of fractions, but this answer brings us to another dimension, if you like, because the examiner could be happy with this, but the examiner could say, write your answer as a mixed fraction. And I'm going to do a skill check with you on mixed fractions in a minute, because that's quite key. But just for now, could you imagine a pizza divided into 30 slices? So a whole pizza would take 30 slices, okay? If you've got 49 slices, how many would you have left over? So the whole pizza takes 30, you'd have 19 left over, and that is it as a mixed fraction. But just a really quick check-in on mixed fractions for you, because I think it's really quite key that you can do this, and if we've established this skill now, we'll have it ready for when we do multiplication of fractions. So here we go. I'm just going to go through the first couple. Can you see the first fraction is 1/1.5? Now, if you count up the halves, you can also see 3/2. We call this, by the way, an improper fraction. It's sort of a posh bit of terminology for it. I often think of it as a top-heavy fraction. So, improper fractions are top-heavy fractions, and we can write those as mixed fractions also. And you can see here I have got 1, 2, 3, 4, 5, 6, 7 quarters. If I write that as 7 quarters, you might be asked then to write 7 quarters as a mixed fraction. And can you see that if you're dealing with quarters, you've got 1, 2, 3, 4 in a whole one, which leaves you 3 quarters left over. Let's try that working in that direction again with this one. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 quarters. How many quarters in a whole one? There's 4. So I've 9, so I need 2 whole ones. And that gives me 8 quarters plus 1 left over. Have a look at this one, 8ths. There's 8 in that whole one, 8 in that whole one, 16 plus 3, 19 eighths, which I could also write as 2 whole ones, and 3 eighths left over. That's a quick visit of mixed fractions, okay? Because now I want to show you how to add and subtract with mixed fractions. As the first example, I've left a visual in for you. You can see that is 2 1/4, and that is 2 whole ones and 3 eighths. Supposing we were asked to add those two together, there are two approaches. The first approach is to consider, well, I can add those whole ones straight away, that's 4. So I've got 2 plus 2 whole ones plus 1/4 plus 3 eighths. Okay, so that's 4 whole ones. Then, if I add these two together, I make the bottom the same. The easiest thing to do here, can you see that 4 goes into 8 if I multiply it by 2? Can you see that? So I can quickly make them the same. Multiply the bottom by 2, multiply the top by 2. My answer is 4 5 eighths, which works fine there, but sometimes it gets a bit messy. So as an alternative method, consider this. And this alternative can be quite useful. So I've got 2 1/4 there, and I've got 2 3 eighths here, and I'm going to rewrite that as 2 whole ones is 8 quarters plus 1/4. I'm going to rewrite it as 9 quarters, and you can see that up there visually, and visually as well you could count 8, 16, 19 eighths. So I could rewrite it as 19 eighths. So the other approach is to move it in straight away to improper fractions. Make this, because I've multiplied the bottom by 2 to make it eighths, so I get them to be the same. So if I multiply the 4 by 2, I multiply the 9 by 2. So that's 18/8 plus 19/8 gives me 37/8. Okay, but if I'm asked to leave the answer as a mixed fraction, I'd have to rewrite that as a mixed fraction. I'm just going to redirect us over to here. 37/8. It is a bit tricky to pull it together at the end, but this approach has other benefits, which I'll show you in a minute. 8 goes into 37 how many times? 8, 16, 24, 32, 4 times. 4 whole ones is 32 pieces with 5/8 left over. So there you are. That's addition of mixed fractions. Okay? But I want to show you a subtraction of a mixed fraction, which is a little bit trickier. Okay, let's have a go at something like this. Okay, so we've got 3 1/4 minus 1 3/5. I'm just in a bubble here going to show you an approach you could do, but which will run into a little bit of trouble. You could do the 3 whole ones, take away the 1 whole one, which leaves you with 2. And then separately, you would have to work out 1/4 and from that subtract 3/5. Okay, if I make them the same number at the bottom, they become 20ths. So multiply the 4 by 5, so multiply the top by 5, which is 5 20ths. If I've multiplied the 5 by 4 to get 20, I'll multiply the 3 by 4, so I've got 5 20ths, take away 12 20ths. Now you can work this out. I could carry this on with you, but you're going to have basically 2 take away 7 20ths, which is a bit messy, and we can do that, but I would prefer, if you've got a subtraction where you've got some awkward mixed fractions, I prefer you to do this, and you have a look and see if you agree it's slightly easier. 3 whole ones, if we're dealing in quarters, is 12 quarters. So 3 1/4 is 13 quarters. 1 whole one is 5/5, so I'm taking away 8/5. Okay, so it's now become a question we're quite used to, and I want to make the 4 and a 5 the same. Remember, same size pieces. So I'm going to multiply that 4 by 5 and multiply that 5 by 4. I wonder if you've noticed now you can effectively multiply these two numbers together to get the same size pieces. So if I multiply the 4 by 5, I get 20ths. Multiplied 13 by 5 give me 65 20ths. Multiply the 5 by 4 gives me 20ths. Multiply the 8 by 4 is 32 20ths, which gives me 6 pulse. So they're the same size pieces. 65 take away 32 is 33 20ths. Now, you'd have got most of the marks in the question for that, unless it says give your answer as a mixed fraction. How many 20ths make a whole? 20. So 1 whole one uses up 20 of those 20ths, leaving 13 left over. And there's your answer. Okay, there we have it then. We've worked with addition of fractions, with mixed fractions. Fundamental for addition of fractions is same size pieces. Well, I hope you enjoyed the video. I'm going to enjoy my apple. If you like what you saw, please don't forget to subscribe and give us a like. And any suggestions you've got, just let us know.